3.2 Absolute Maximum Minimum on an Interval. In this video, we will analyze the algorithm and its restrictions, and we'll try to understand how to solve problems where we need to find absolute maximum and minimum, right? So for that, we know one thing, that if we have a function, let us say f of x, and we are given that x belongs to, or it is within, a restricted domain, that is, it has a boundary a to b, where a signifies the lower bound and b is the upper bound, then in that case a function will definitely have absolute maximum and also absolute minimum, right? It will have both the values. The only condition here is that the function should be continuous within the domain, and the restriction, I should say, which is the restriction, is f of x should be continuous within for x greater than equals to a and less than equals to b. That is the restriction which we should follow, right? Now the points which we need to check for the function to have maximum or minimum value are just 3 points. So one is f of a. So it could have absolute maximum or minimum at a itself, one of the boundary conditions, or at f of b, these values, or at f of, let me say, c star. Now what is c star for me? C star is my critical number. Critical number is a value where f dash c is equal to 0 or f dash c is undefined. So that could be another position at which the function may have absolute maximum or minimum value, right? So this is the base for the whole chapter. Now let me illustrate these things with few examples, right? And then we'll take up more videos solving those examples, correct? So here the idea is to understand the algorithm first and how to approach or how to solve the questions based on absolute maximum or minimum, right? So let me give you a few examples which will help you understand all these concepts, right? So I'll draw a few graphs here to just illustrate these examples, correct? And then we will take up videos to solve numerically and find the values for extreme values for maximum and minimum. Let's take a simple graph which is always increasing. Let us say we have a function like this, right? Now that, is kind of an exponential growth, right? Now here, if I ask you, do you have any local maximum minimum in this graph? No, you don't. It is always increasing. So there is no point on this function where you could have absolute maximum or minimum, since it goes from minus infinity to plus infinity, and all throughout its domain it increases. But look at it. What happens when we restrict the domain? If I say check the values from a to b, where a is my lower bound and b is my upper bound, in that case what happens? At this point we are just considering the function from a to b. Now if you consider the function between a and b, then you have extreme values. At a we have absolute minimum and at b we have absolute maximum. So the function as such may not have any local maximum or minimums and may not have any critical point in between. I mean, if you find the derivative in between, it is neither 0 nor undefined at any point. Now even for that kind of a function, you see we have absolute maximum or minimum, correct? Now let's consider a function like this. Let's say we have some function like this which have number of terms. Now in this kind of a function, we do have some maximum minimums, right? All these turning points. But suppose if I restrict the domain with a boundary condition and say, well, my boundary condition here is, that is the value of A and this is the value of B. Let us say, let me put it here, B. Now, what is absolute maximum minimum? In this case, what we will do is, we will check many points. We'll check points at A and at B, right? And in between, the critical points. Critical points in between are these two, right? So this happens to be a bit lower than that one. So let us say this is my C1 and that is my C2. I got two critical points here. So for this particular function, we'll check the values at A. So we get a value at A which is kind of here, right? Then value at B, the other boundary condition which is right there, a positive value. And at C1, which is my turning point, I get a value which is lowest. So at C1 I get absolute minimum. At C2 I do have a local maximum, but that is not higher than the value at the extreme FB. Do you see that? But in any case, if we try to find the values of the function f of x, this is my function f of x, bounded between A and B, at A, B, C1 and C2, then we can see just by comparing, simply by comparing the magnitude of those values, right? Which one is maximum, which one is minimum. I should not say magnitude, I should say the value, because the negative value will be the least, right? So that is how we can find absolute maximum and minimum. Now here I have one more example to give you or to share with you, and that is to cover up for undefined derivative. Can you give me some examples where we may have maximum or a minimum and the derivative is undefined? How about the absolute function? If I draw this absolute function like this, you can see that and if I have a boundary condition, let us say my boundary condition here is this. That is the A value and this is my B value. Okay, so I'm saying that is my point A and this is my point B. And if I'm considering this absolute function with the boundary conditions between A and B, then I have to check values at A, which will give me this value. So that is f of A, right? And then f of B is here. So this one is f of B. Now, if you find derivative of this function, then you know derivative at this corner will be undefined. And this point f of C actually gives you the minimum value for the function. So the critical number for this particular function will be at the vertex or the turning point or the corner of this absolute function. Here it is a critical number since the derivative of this function is undefined. So therefore we need to check the values of the function at the boundaries, which are A and B, and also at the critical number C. And if you compare the three values, you get your answer. And that is, you have absolute maximum in this case for f of A, that is the maximum value for this particular graph, and the minimum will be at f of C. I hope that gives you a very good picture of how to find absolute maximum and minimum on an interval for a given function. Correct? Now we'll take up examples to solve and find out these critical numbers and then evaluate the value of the function on the boundaries and at the critical number to figure out absolute extremas. So when we use the term extrema, we mean both maximum or minimum. Okay, I hope you're ready for that. Let's go ahead and solve some problems to find absolute maximum and minimum values. Thank you and all the best.